Hi, these are a series of educational video on LoRa chipset. In this part, I'm going to explain about SEMTECH reference design and crystal oscillator block diagram. First thing first, we should download the reference design from SEMTECH website. We should go to this URL, and from datasheet and resources, we can download the target reference design. For instance, European, North American, and Asia market have different spectrum allocations. We should know, then we can download the target reference design from this page. Once we download the file, we can easily unzip and access to all the project requirement files. So the benefit of this file is an open source design file. We can access to all the files even for board manufacturing. For instance, pick and place file for assembly house and also bill of material to purchase the component and also schematic. The main file is here, reference design, which is designed in Altium Designer software. Once we open the file, we can see the schematic and also PCB layout of the board. The crystal oscillator is the main timing reference of the LoRa chipset. It is used as a reference for the PLL frequency synthesizers and the clock signal for all the digital processing. We can run the LoRa chipset with two types of crystal oscillator. Application number 1, 32 MHz passive crystal oscillator. Application number 2 is 32 MHz TCXO crystal oscillator. For instance, if we download this reference design from SEMTECH website, we can see the left hand side they are using TCXO as a crystal, and then the right hand side they are using the passive crystal oscillator. Passive crystal oscillator has to connect to the XTA and XTB of the LoRa chipset. So in this case, it doesn't require to connect the external foot capacitors because SX1262 has internal programmable capacitors which is connected independently of the pins of XTA and XTB of the device. So we can easily calibrate and also change the value of the capacitor through the program. TCXO stands for temperature compensated crystal oscillator, and XO is the old acronym for crystal oscillator. TCXOs are used to provide a higher level of temperature stability than the standard crystal oscillator. SX1262 adapts 32 MHz TCXO crystal oscillator to provide and ensure high accuracy rate of frequency. The schematics show how we can connect a TCXO crystal oscillator to the LoRa chipset. As you can see, we only use two pins, XTA and also DIO3. So DIO3 is going to use as a switch of the TCXO, and it can provide the power to the crystal oscillator. And we don't need to use XTB, we can leave it open. The first question is, what would be the voltage value of the DIO3? As they mentioned in the datasheet, is programmable DC voltage from 1.6 to 3.3 volt. So if we refer to the datasheet, we can see the operation range of the LoRa chipset. So we can go to the first row, we can see the level of the voltage which the LoRa chipset is going to operate. They mentioned minimum is 1.8 and the maximum is 3.7. Okay, let's say we are going to use the typical value is 3.3 volt. The voltage regulation for TCXO voltage is configured to be 200 mV below the operation voltage of the LoRa chipset. This is the formula. As you can see, VDD operation has to be more than voltage TCXO plus 200 mV. If we refer to the table from the datasheet, we can see the range of the voltage which we are able to configure DIO3 is started from 1.6 to 3.3 volt. In the previous slide, we assume we are going to use 3.3 volt as operation voltage. In this case, we can choose any number between 1.6 to 3 volt, then the result would be less than operation voltage. Thank you for watching. I hope you found it helpful. If you like this video, please make sure to like and subscribe. See you in the next one.